Welcome to CPAK. I want to introduce Walter. Walter Cruttenden is one of my heroes because he is a cutting-edge guy, he is a dynamic doer, and yet he's into the being. He's a grounded fellow. He's a great friend. And Walter, come up here and do your thing. Amen.
Pleasure to be with you. I love this event because we've been doing it for about 15 years or so. It's our 11th one. We skip a year now and then. And I always get to see so many friends that we've grown closer and closer together over the years. And everybody's always emailing me with new findings, new bits of information. And so I have a bit of an advantage in some of my talks in that I get to use some of this information. So hope this comes out okay. There's some very interesting information going on now at Caltech. And basically they found that something massive is pulling on our solar system. And this is important because, as we wrote about in Lost Star Myth and Time about 15 years ago, if we are to have a cycle of ages, golden age, dark age, just like we have a cycle of the day or a cycle of seasons, then it too probably has a celestial cause. And so, when we first wrote about this, there was no one really looking for any large mass outside of our solar system, and we were kind of considered crackpots. But since that time, kind of the whole bandwagon has come along, and Caltech and just about every major astrophysicist in the world is renting the largest telescopes, or taking time on them to look in the direction of Orion. And so we'll talk a little bit about that today. First, I'd like to go back to Hesiod. Hesiod lived around 700 BC or so, born probably 750 BC, contemporaneous with Homer. And he was considered a great historian for thousands of years, just really up until the last few hundred years, when people recognized that he was talking about a long-lost golden age. And since that's not in our lexicon today, they've reclassified Homer as a poet or a mythologist. He's no longer a great historian. But I'm not sure that that's true. You know, when I was going to school, they taught us that Christopher Columbus discovered America, and I wondered why. I'm the guy on the far right. And basically, the teacher, with all sincerity, told me, well, they just didn't have boats that were big enough back then. And it would have been too treacherous of a journey more than 500 years ago. And so I didn't quite believe that, but filed it away, thought about Viking ships, thought about other ships. And then there was a discovery made just a couple years later, early 60s, and they eventually found 9 ships buried under the sands of the Giza Plateau. And one of those ships, the solar boat of Khufu here, turns out that it's about twice the length of any of Columbus's ships. The Nina, the Pinta, the Santa Maria were all about 70 feet or so in length. And this boat is 140 feet. So they definitely had ships that were big enough. And you might look at this and say, yeah, but it's not very well constructed. Those sides aren't very high. How could that possibly make an ocean voyage? Just consider that it's sitting next to the greatest built structure in the world, the Great Pyramid. And if they could build that, they could certainly add on a couple boards or two here to make this thing get across the sea. But what's interesting, of course, is that this is not only 500 years old, but it's actually 4,500 years old. So I'm pretty convinced that mankind had the ability to travel across the seas long, long before Columbus. And so ever since the 6th grade, I've been trying to rewrite and figure out history in my own mind. And to do that, my mom bought me all sorts of books on ancient cultures, and And that got me into this whole labyrinth of Graham Hancock's work and Robert Schoch's work and John Anthony West. And of course, we've all been together here at CPAK. We're still going. In Hesiod's time, he kind of wondered, why things were changing. He sort of lamented the lost silver and golden age. And he spoke beautifully about this time. He said it was a time when men and women lived very, very long ages, several hundred years old. It was a time when the earth gave freely of itself. Imagine if you're hungry, there's just food around, that sort of thing. And when you died, it was like going to sleep. So it sounds very nice. We'd love to know if that's true. But he seemed to think it was true, and he wondered why it went away. But he wasn't the first to ask this question. There's one of the oldest books in the Bible is the book of Job. And nobody's quite sure how old it is, but because it seems to be based on a proto-language. It doesn't have any mention of Hebrew universities. It doesn't say the son of so-and-so and the son of so-and-so, like so many other ancient books in the Old Testament. But here Job is asking, canst thou bind the sweet influences of Pleiades or loose the bands of Orion? And it's sort of a rhetorical question. He's saying, can't we just stay in the higher age, the sweet influence? And the Pleiades is thought to be a point in space that perhaps we go closer to at times that brings on this sweet influence. But in the same sentence he says, or loose the bands of Orion. And of course, he's kind of saying, no, we can't stay in this higher age any more than we can break apart these stars in Orion's belt. So if you really think about it, in modern physics terms, stars are these massive objects. They live for billions of years. And if there's any influence, it's them on us, not us on them. And so, but the stars do affect us in one way. And I'm not talking about astrology. I'm just talking about celestial mechanics right now. And we know that, of course, the Earth spins on its axis, and that gives us the cycle of day and night. And, just 3 hours ago, we were all in a subconscious state, and this world out here kind of didn't exist to us. And of course, now we're in a waking state, and we just barely remember our dreams, if we remember them at all, and we think that that's just sort of fantasy. And yet, we go through this change every single day as the Earth's spinning and our body is adapted to the light and darkness. And yet we hardly think anything of it, this huge change in consciousness caused by this first celestial motion, the Earth spinning on its axis. And of course, there is a second cycle here, the cycle of the seasons. And, it's really beautiful. We kind of think of a tree just sitting there, but when you look at it kind of over time, it's taking off its coat and putting on different coats with each season. It's watching all the terrain around it change. It's a magnificent show, and of course all the plants are just blooming out of the ground in the spring, giving their fruit in the summer, decaying in the fall, and faking dead in the winter, or sometimes completely dying. And likewise, it's also this second celestial cycle, the Earth's revolution around the sun, affects trillions of animals. And it's almost like somebody just stirs the heavens a little bit, and we have all these beautiful patterns here. You can see some of the birds and fishes and animals will hibernate or come out of hibernation or spawn or just migrate in huge masses. So those first two celestial changes cause these major changes. So if there is a third celestial motion going on, you might expect that might be having some effect also. Some years back, I went up to visit the biggest telescope in the world, the Keck, on Mauna Kea. and I was there with George Marcy, or Jeff Marcy. He was the head of astronomy at UC Berkeley at the time. And it's really fun. He was looking for planets around other stars, and these planets were exoplanets. And so they'd stay up all night, they'd take in light, just tiny bits of light from other stars, and they would slowly find out if there's changes in the pattern of this light coming from these other stars. And they'd compare it to a day ago, a week ago, a month ago, a year ago, etc. And when they see this star's the light pattern changing, they know there's probably some planet there that's blocking out part of the light. It was a fun trip. You know, on the way up, it's 14,000 feet. You go through these different layers of clouds that are sort of like fog, but it's Hawaii, and so there's cows grazing up pretty high there, and you can't see the white cows in the fog very well, so they have these beware signs. Anyway, today, as mentioned, all these major telescopes are pointed at one area in the sky. And it's mostly on Orion and the nearby stars in that area. It runs roughly from Sirius to the Pleiades. And this is maybe 20, 30 degrees of the sky, generally towards the southwest. And a lot of people are looking there. And the reason they're looking there was all set off maybe 10 years ago by Mike Brown and some of his fellow astrophysicists when they started finding other dwarf planets. So we'd known for a while that Pluto was not as big as we thought it was. And so they were wondering whether to reclassify it. But the really sort of nail in the coffin was when they started finding Sedna and Biden and all these other dwarf planets about the size of Pluto. And they had to either add all these to our solar system or create a new class of planet. And that's what they did. We now have classical planets and dwarf planets. But his daughter, I understand, was very mad at him for essentially killing Pluto. And so he said, "Don't worry, honey, we'll find you another planet." And sure enough, he's been on this quest because what they learned was that to have all these other planets have these elongated orbits, all inclined to the plane, all with their perihelion on one side of the sun, it must be something very, very big that causes this pattern. And so I'll play his own words here.
What we have discovered is that numerous features
Is the sound working back there? Sean?
What we have discovered is that numerous features of the Kuiper Belt, a field of icy debris beyond the orbit of Neptune, can be understood if the solar system possesses an additional ninth planet that resides well beyond the orbits of the known planets.
When we looked at the outer solar system, we realized that while most of the very distant objects, these objects beyond Neptune, beyond Pluto, most of these objects, they all go around the sun and they're all sort of pointing off in all different directions. But the most distant objects all swing out in one direction in a very strange way that shouldn't happen. And we realized that the only way we could get them to all swing in one direction is if there is a massive planet also very distant in the solar system, keeping them in place while they all go around the sun.
So this is cool because suddenly we're not so crazy. There is a big mass out there. It is affecting our solar system. Of course, they're not looking for a star at this point. They're just looking for a planet. But a lot of people are looking. Here's one.
And we started looking at this and thinking, this must be either a coincidence or it's caused by something else. It can't be caused by a planet because that's crazy. There are no planets out there. I went from trying very hard to be skeptical that what we were talking about was true to suddenly thinking, oh, this actually might even be true.
So the object itself likely is more massive than the Earth, probably a little bit less massive than Neptune. It sits right in between that terrestrial to giant icy planet range. Its orbit, unlike the orbits of the known planets, is not nearly circular and planar. Instead, it is exceptionally wide, 20 times bigger than the orbit of Neptune. The orbital period of the Earth is, of course, 1 year. Right? The orbital period of Jupiter, the big player in our solar system, is about 10 years. The orbital period of this putative ninth planet is 20,000 years.
So there's a couple interesting things happening here. When they first started looking, they were looking for 1 to 2 Earth masses. Then they went to 5 to 10 Earth masses. Now many people are at 20 plus Earth masses. I've seen some papers up to 99 Earth masses. And the reason is they keep finding more stuff that is affected. It's not just the dwarf planets, which are stretched in these elongated orbits that are highly inclined to the plane. It turns out that all the major planets, big, heavy masses, Jupiter, Saturn, Uranus, and Neptune, are pulled down about 6 degrees from the sun's equator. And this shouldn't be happening without a big cause. So as they kind of look at this whole problem, they just keep needing more and more mass to solve it. And so that's what's kind of going on right now. It's pretty fun. They've been looking for planets before, and I'll give you 2 quick instances. One, when Uranus was found in 1781, they watched its orbit for a while. They noticed that at a certain point it kind of seemed to be going off course. It showed a little perturbation. And so that told them that, oh, there's probably another mass out there that's affecting Uranus's orbit. And so the math was new, but they did it and they figured out where this other planet should be. And within 2 days of the math being complete, they nailed the position and they found Neptune. And it was actually found by several people. Adams and Leverrier are given credit the most. And then they watched Neptune for a while. And, after 50, 75 years, something like that, they started to notice that it too was perturbating. So there must be another planet that's affecting Neptune. And again, they did the math, and in 1931, they found Pluto. And it was found within about 48 hours of the math being complete. So it's interesting. Now they're not just looking at one planet perturbating to look for the next one. They're looking at all the planets in the solar system being tugged sort of down and towards the southwest. And they happen to be looking in the direction of Orion, which just happens to be the direction that many of our ancient cultures had an interest in. Here's the shape of Orion's belt. You've all probably heard of Orion correlation. One of our speakers a few years ago talked about this in depth, but the 3 great pyramids in Egypt seem to mimic this, and of course they have many myths about Orion. Really, I think it's Osiris in Egypt, but some of the Egyptologists can correct me on that. And then in Mexico, they also have 3 very similar pyramids, the greatest pyramids in Mexico. So something's going on. The ancients are very interested in this area of the sky, and of course now modern scientists are very interested in this area of the sky. Here's just a look at those pyramids from above, comparing it to Orion's belt. And of course, as you know from my book, Lost Star of Myth and Time, I'm also interested in this very area of the sky, especially Sirius to the left and the Pleiades to the right. Sirius is just an amazing star that's been the topic of much conversation by scientists for the last 1,000 years or so. Many books have been written on this. It doesn't seem to precess like the other stars. I talked to Jed Buchwald about this. Jed is he's an astrophysicist and head of the history of science at MIT. And he said that he just thought that maybe the horizon in Egypt was such that it just made it look like Sirius wasn't precessing. But then I talked to people in Canada who have also been plotting Sirius for a long, long time. They have a much different horizon, a much different latitude, of course, and they found the same thing. An interesting point about Sirius is that it's the heaviest star in our local neighborhood. So in Einstein's world, it makes the biggest dent. And it's also a binary itself. There's Sirius A, which is that big blue dot, and then Sirius B, that little white dot next to it. And Sirius B actually has as much mass as our own sun. It's much, much smaller because the atoms are super condensed, so that a teaspoonful would weigh about 4,000 pounds, about 2 tons. And so we think, this B goes around A roughly every 50 years or so, and it's creating this big gravity well. And so we're trying to figure out what's going on with the star as much as we can using all our modern instruments. But once again, the ancients were also very interested in this star. The Shinto, which is the oldest religion in Japan, they align their temples towards the southwest, towards Sirius. Sirius is sometimes called the New Year's star because it hits its zenith around the stroke of midnight on New Year's. That's will happen again this year. It should be moving through the calendar. Sirius is one of the topics of discussion on the Dendera ceiling. This was pulled out of Egypt, literally blasted out of the ceiling by Napoleon's men and brought to the Louvre. It's really beautiful. Modern day scientists have looked at this, and this is actually a quote from one of Jed's papers where he's interpreting the Dendera plate there, this bas-relief. And he's saying that the vernal points mark the equinoxes at certain times, and these circled numbers on the lower right indicate the corresponding positions of Sirius. And Sirius remains about the same distance from the equinoxes and so from the solstices, both markers of the sun, throughout these many centuries despite precession. And you can see how the two kind of move similar. And that just shouldn't be happening. So rather than rewrite my whole book to put in some of this latest findings that the ancients and the modern physicists are finally getting together looking in the same area of sky, I just wrote a chapter 10. It's out in the book room if you want to grab a copy. And it goes into much more than I have time to discuss right here, but I'll mention one thing, and there's something called resonance. Planets, moons, they fall into resonance with each other so they don't kill each other. In the early days of our solar system, there was just a lot of stuff knocking around, and stuff was blasted out, and just anything that didn't fall into these resonant patterns, didn't dance with each other, was lost. And so today you see that the moon is in a beautiful resonance with our Earth. It's tidal lock. So even though the moon spins, it spins at the same rate that we're going around the sun. And so we just see one side of the moon all times, even though we go completely around the sun. And many other planets have the same pattern. For example, Pluto and Neptune, they go in and out each other because Pluto's orbit is inclined to the plane of the major planets. So if they didn't have this kind of worked out, well, you go here when I go there, then they'd be bumping into each other, and that would be a bad thing for both planets. And so it's a 3-to-2 relationship. Pluto goes around our sun exactly twice for every 3 times that Neptune goes around. So when planets are in resonance, you know that they're part of the same gravitational system. They're connected. Turns out that Sirius B goes around Sirius A in 50 years, and that's exactly a 5-to-1 integer of what's going on with Pluto's orbit, about 250 years. Matter of fact, it's 5.00 to 1. So there's some gravitational relationship there, and we don't know exactly how it works, but it could be that Einstein's gravity is giving us a bit of a clue. And so they built this, Einstein came up with this theory in 1916 that there are actually gravity waves. And people have been trying to figure out how to prove that. So 10, 20 years ago, they started building this LIGO, this huge interferometer with lasers that can detect any ripples in time-space. And since they built it, they have discovered these ripples. And so they discovered the first one in 2016, exactly 100 years since Einstein predicted gravity waves. And so I think that's kind of how is one factor in how we're bound to Sirius. So even though Sirius is so far away, you wouldn't expect us to be gravitationally bound. The fact that Sirius B is making this huge gravity well around Sirius A, I think it kind of affects us like distant surf affects our shoreline. You know, I go surfing down here sometimes, and after a big storm, you see the beaches completely change. If the storm's from the south, the beach is etched one way, and if the storm's from the north, the beach is etched another way. And you never see these storms because the best surf comes from storms in New Zealand, you know, a great south swell. It's so far away, the waves are really spread out. You have time to catch one and still paddle out and catch the next one in the set, that sort of thing. But they change our shore, and I think that's kind of what's happening with our solar system. So our solar system is sort of the LIGO experiment. Something's going on very distant, and it's rearranging all these dwarf planets, pulling them down, elongating their orbits, etc. But anyway, a lot of research going on there, and we're just on the verge, I think, of figuring it out. One of my last points here is just the last mystery school that really talked about precession is the Mithraic school. They're found about 200 of these Mithraic temples throughout Europe. And they were really well preserved because they were built underground. They tend to be stars on the ceiling, and they have this tauroctony at one end and sometimes a zodiac on the other end. And the Christians, and they flourished around 200 BC to about 200 AD. And the Christians thought it was just a pagan religion. You know, Christians were coming along in the sort of the darkest of the Dark Age to help bring a little light back, I think. Anyway, they used these temples as trash cans, and so all this trash composted and had the beneficial effect of preserving these temples. So they're still digging them up to this day. They find one and get excited. But what's interesting about the Mithraic temples is they have these two boys, Cautis and Cautapates, on each side that hold a torch up or a torch down to mean we're in an ascending age or descending age. The light's coming in or the light's going out. Some of the other iconography you see in these things, you know, they thought it was just all pagan symbols. Now they know it has to do something with astronomy and something with precession. And we actually put this in our film, The Great Year. I don't know how many of you have seen it, but I'll just play a very short clip of...
There's one sun which is part of the planetary system, and there's one sun outside the solar system. And this allows Mithras to both be the sun, Mithras, Sol Invictus, Mithras, the unconquerable sun, and also seem to be operating for the sun or on behalf of the sun.
So when we went to film him, we just wanted to hear his thoughts on Mithras. And we didn't know he was going to get into this two-sun subject, but he did, and so we captured that, and that's kind of cool. Sort of further clues on telling time, you know, we just use the zodiac as sort of numbers to see where we are in the great year. The great year takes roughly 24,000 years. Precession actually has a variable speed because it's dictated by Kepler's laws, but it's moving a little slower right now, so it looks like the whole period would take over 25,000 years, versus when it speeds up, when the two gravitational bodies are closer together, then the whole cycle would look like it would take less than 24,000 years. But it'll average about 24 over the period. And the period, the side on your far right is sort of the descending age, with the peak being about 11,500 AD, the depth of the dark age being about 500 AD or so. That's pretty much when every major civilization had fallen. Harappa, Mohenjo-daro, the whole Indus Valley just went from indoor plumbing and heating to just mud huts by the time of the Dark Ages. Same thing with Mesopotamia, Sumer, Akkad, Babylon. Great civilizations, massive ziggurats, the famed Hanging Gardens of Babylon. It all disappeared, and by the time of the Dark Ages, it was tents and camels and a lot of sand. It just really, really changed. In our children's book, we help kids understand how to tell time in this thing, and it's really just a microcosm of what we have on a wristwatch. So each of the 12 constellations is like the 12 numbers. The equinox moves in the same direction to tell time in the great year. And if I can just read this briefly, we can tell where we are in the great year by seeing where the sun is on the equinox. That's the day when day and night are of equal length. The sun can be seen on this day in a different constellation of the zodiac about every 2,000 years. Because, it's roughly 24,000 years, but it means it takes about 2,000 years to go through each constellation. Again, we're moving a little slow now, so it seems to take a little bit longer to go through each one, but it will average. 12 constellations are just like numbers on a clock. The equinox is the hour hand, and anybody can see where we are. You just look at the date of the equinox and see what constellation there is. And if you look super closely and you have really good instruments, you can see it's moving about 50 arc seconds per year. But at that rate, it takes about 70 years or so just to move 1 degree. But you don't have to wake up early to see it. You can also just look at it after sunset and see what constellation it is in. But you do have to use the same marker. So use the equinox. That's actually better than the solstice because the equinox is moving so fast across the sky. So right now, in the early part of the 21st century, you can see the spring equinox is in Pisces. At the dawning of the age of Aquarius, we've all heard that term. But the ancients really didn't use the spring equinox. They used the autumnal equinox. And it's to the lower here where sort of the sunny part is. And it makes everything flow really well. So you can see we're just sort of coming out of the lowest of the low ages. Iron Age, the Greeks call it Kali Yuga, the Indians called it. But we're just barely waking up. We've had our Renaissance. And so that's kind of what I wanted to cover today. And after I had this whole presentation prepared, some news came out just in the last few days. And it was published in Cornell University. And it says, what if Planet 9 is a primordial black hole? And of course, a black hole is a type of star. It's one of the scenarios that we have printed in Lost Star. It was published again about 15 years ago. And so what's happening is since they're not finding a planet, and they should have found a planet by now, they're looking at other scenarios. Unfortunately, this scenario will take a while to figure out because a primordial black hole is just some theoretical object that's only like 5 centimeters or so. And so it virtually ensures they'll never find it. But I think, this scenario will play out for 20 or 30 years, and then we'll get on to more serious business. So anyway, I don't think we should have reclassified Hesiod. I think we should give him a break, continue to think of him as a great historian. And let's all help them out by doing this work, attending conferences like this so we can support this type of research and prove them right. Thank you.